Up next, we have Dora Demszky. She's a PhD candidate in the linguistics department at Stanford University. Her research focuses on developing and applying natural language processing methods to support student-centered education. Dora will be online to answer questions during her recorded workshop using natural language processing to analyze U.S. history textbooks.
Hi, everyone. I'm Dora, and I'm a fourth-year PhD student at Stanford. My research focuses on natural language processing and its applications to computational social science and education in particular. I'm super excited and honored to be here at this Women in Data Science workshop, and I'm very grateful that you're here and listening, and I really hope this is going to be a fun experience for you. I'm going to jump right in because we don't have a lot of time, so I'm going to be focusing on a project that I recently worked on with my colleagues and which I turned into a workshop for you. This focuses on the use of natural language processing to analyze US history textbooks. As I mentioned, this work was done in collaboration with my colleagues, including Lucy Lee, who is now a PhD student at UC Berkeley, and with Professor Trisha Bromley and Professor Dan Juravsky. So, to give you an overview of this workshop, I'm going to start with an introduction, then highlight the few research questions that we're going to focus on. And then I really want to make this as interactive as possible by presenting a notebook, which is a Python notebook that will show you how some of the scripts can be used from our toolkit to analyze text and illustrate how we can use that to answer the research questions that are relevant to this project. But I really hope that this could be something that's interesting and useful to you for your project. So think of this as like sort of a case study or example for a lot of possible things. One thing I want to mention is that for the interactive part, especially, some knowledge of Python is kind of important. So it's okay if you don't know Python or don't have experience with data wrangling or processing in Python, but it will make this may make part of it a little bit hard to interpret. So what I would encourage is that you just listen and don't try to like understand every single detail if you don't have a Python background, but rather just try to like understand the key highlights. And then Python is a language that's pretty easy, so I would really recommend that you take a crash course or something, and that will really prepare you for understanding a lot of what's being discussed here. So let me start with the introduction. So we are focusing on US history textbooks because they're the most widely used instructional technology around the world. They convey cultural and social values to students and impact their beliefs about people and ethnicities different from themselves. But textbooks are not neutral, and one research area in education is to understand how textbooks are portraying people in varying ways. Most textbook content analyses rely on people reading and hand coding textbooks. For example, a coding protocol might ask questions about how often a social group is mentioned and whether they're talked about in the context of a topic such as human rights. These traditional methods tend to lack precision and be resource intensive. We focus on textbooks from Texas, which has the second largest student population in the US, with 5.4 million students enrolled in its K-12 public school system in 2017. Texas is a major textbook market for publishers, and so the state has a significant influence on US textbook content. Texas has also been at the center of several controversies. In 2015, a new social studies textbook adoption was launched. This curriculum became the subject of many news headlines, and some articles stated that the curriculum promoted conservative ideas. The goal of our work and this workshop is to apply natural language processing, or NLP for short, to textbooks to answer questions that textbook researchers in education care about. We focus on three main research questions, which are inspired by related work in education. The first one is, how much are different groups of people mentioned in these books? The second one is, how are different groups and individuals described? And the third one is, which topics are prominent and how do they relate to groups of people? In this workshop, I'm only going to touch on the first two research questions because the time is quite limited, but our toolkit, which I will give you the link to very shortly, and also our paper has a pretty extensive description of all the analysis we did and all the research questions. So I hope those can be very useful to you. And I'm also happy to answer questions We focus on American history textbooks, which are purchased in Texas between 2015 and 2017 for middle and high school students. We obtained Texas textbook purchase data from the website of the Texas Board of Education, and then performed a lot of manual cleanup and disambiguation to standardize all textbook titles. We kept the 15 most widely purchased textbooks. This includes combined volumes that come from the same series. We ordered and scanned these books manually, except for 7 books that had PDFs available online, and then applied LB Fine Reader, a software for performing optical character recognition, or OCR, on this data. We used the resulting text as our data with very minimal post-processing. To brand what we learn about text and demographic data, we obtained district-level student demographic information from the National Center of Education Statistics. We estimate the political leaning of each county based on their two-party vote shares in the 2016 elections. I want to introduce a running example from one of our textbooks to illustrate our methods and analyses. Please feel free to stop the video here and take your time to read. So as a reminder, our first research question addresses how often different groups of people are mentioned in these textbooks. We applied co-reference resolution so that references to the same people or person will be counted together. This is not something I'm going to show you in the tutorial, so this is just a pre-processing steps, but we do have scripts, I believe, in the GitHub that can help you do the co-reference. We also identified common nouns that designate non-named people, such as pioneer or Mexicans. Our way to do this is to extract hypernyms of human, person, people, and social group in WordNet, which is a lexical database for English. I highly recommend using WordNet. It's a pretty comprehensive and carefully curated database. We use named entity recognition to pull out words designating named individuals. This is something I'm going to show you in the tutorial for how we did it. And then we standardize names using their official name from Wikidata and focus our analyses on the top 100 most common named entity recognized entities. Our list of common nouns include unmarked terms such as engineer or family, as well as terms specifying the demographic, which we determine manually. We also consider cases of intersectionality, such as Black women, which would be categorized as both woman and Black. For named entities, we use Wikidata to identify their gender, but we had to identify race using manual inspection because race wasn't always listed for white people. In this talk, we only focus on the most frequent demographic categories, but it's very important to keep in mind that people in real life may identify with with many different categories, including ones that are not discussed here. So to jump right into the first tutorial on research question 1, here are some steps that you need to take. So if you want to follow along, which is totally fine if you do it after watching this workshop, but basically there is a GitHub repository that will, Lucy and I prepared this, and we provide pretty extensive documentation on how to set everything up and download all required packages and what format you should have the data in. So I would recommend reading that first, and then you need to run Jupyter Notebook in the terminal once you download the repository and open tutorial.ipynb, which is the notebook. So we're going to focus on, as I mentioned, for the first research question, which is how often or how much are groups and individuals described in these books. And basically, this part is not the most interesting here. We are just loading some data. But basically, what you want is a directory where that contains a single directory that contains your documents in separate text files. And once you have that, this script should work for your data as well. So here we are getting the text for each book. So books here is a dictionary where each key is a title of the book, and then the values of those are basically a list of lines. So here you see one line is about one paragraph because we separate lines by the new line token. So if there's a new line, then we split it, and that means that usually paragraphs have a new line token but it's not that crucial, how you exactly separate it. That's not the main point here. You probably want to separate it minimally at the sentence level, and then, beyond that, it doesn't really matter. Then we have basically a JSON file, a dictionary. You can check all this out in the sort of what format we have this in our GitHub, but basically you you want to have a dictionary that maps your titles. This could be newspapers, name titles of newspapers, and totally different demographics. Here, demographic information, but here what you use is like the median proportion of Democratic votes in the counties where the book was purchased. You don't need to understand how that was obtained, but basically, if you do want to ground your analyses in some kind of social phenomenon or social information, it is helpful to like it can be a very interesting analysis, and like political affiliation is a really good one because it can show you interesting patterns. But there's a lot of other things you can do, including, I don't know, demographic composition, and like a bunch of other things. It really depends on your particular interest and use case. So this plotting part, you don't need to worry about now. You can go back and read it more closely and understand what you're doing. Here is an important part that I wanted to touch on, which is the dependency parsing. So we're using Spacy, which is this general purpose parser and tagger, meaning that it does a lot of things. So it does tokenization for you, sentence splitting at first, tokenization, then does part of speech tagging, dependency parsing, and named entity recognition. These are all things that are pretty standard natural language processing tests. So you can read up on all of that, and Spacy has a pretty nice website. Obviously, it's not perfect, as nothing is really perfect, but it's a pretty standard and easy to use model that you can, or toolkit that you can use for just like by loading it in a single line. So it's very easy to use. So here what we are doing is we are basically parsing each of the lines in each of our books. And that literally is like, all you do is like NLP parenthesis line. That does all the analysis for you. It can take some time. So if I recall correctly, for these 15 books, it took at least 15 minutes, if not more. It really depends on the size of your documents. So, so that's why I'm not running it real time in front of you, just because it takes time. But yeah, don't be worried if it's not immediate for you either, because it's doing a bunch of different analyses. So next, we're loading that word list that I mentioned in the talk. So basically we have, I mentioned we had this categorized list of nouns. And this is the CSV file that represents that. And you can read more about it on our GitHub, but basically it should be in this format where there's a word and then a particular demographic category, which includes gender, race, and ethnicity, whatever is like important for you. And then and then also like in terms of what sort of categories, like race and ethnicity, but we also have gender. So for example, later on I'm converting each of these into dictionaries, which you can also look at more closely. I'm sorry that some of the things I'm sort of skipping through. The reason is that I think I really want to highlight the key parts that are most difficult to understand if you're new to NLP, and I'm going through those parts fast that are relatively straightforward, and if you just spend some time on your own, you will understand exactly what's going on here. So here, like say, like Lord is man. So here we have a dictionary that was directly derived from this CSV file that maps a word to a particular demographic category. So now here's like, the meat of this counting, where what we are doing is basically going through each of the parsed lines in the books, and then each token in each line. And then each token has a part of speech tag. So we're not considering nouns, either nouns or proper nouns or pronouns. We're not considering other terms. And then we are checking we're checking if any of those words are in our in one of the word lists that are marked for a particular demographic. So, for example, man is marked for gender, obviously, and then we increment that count. And one more important thing is that sometimes we want to also, like, there are some words that are unmarked, such as, like, let's say you have African person. Person is not marked, but African is marked. So the same term can be used as an adjective in the noun. So we consider both. So basically what we're doing here is we are not only looking at that word, but also the previous word, so the modifier, and checking if that word is in one of the marked categories. And then if it is, then we increment that count. So what we end up with is basically like a table with our data frame where each book plus demographic category combination has a count indicating the number of terms that are referring to that demographic category in that book. As I mentioned before, we are only focusing on the most frequent categories. There are several that are not represented here, and that's unfortunately because many categories, including like Asian American, for example, occurred very rarely in the textbooks, which is a fact about, I have just like another fact about the content of US history textbooks. And so it's very difficult to do analysis when there are only like a handful of occurrences of a particular term. Another thing that's very important to know here, which is just, generally an important data science kind of perspective is, you got your data. It might involve some manual curation and automatic analyses, but there can be a lot of biases in there. So for example, one very important bias that's actually very important for our analyses is that a lot of terms that are unmarked, so such as farmer, for example, is not marked for ethnicity or race, but oftentimes when it's unmarked, the interpretation is sort of the majority demographic, which in this case is, in the case of US history, is white. And so even though, the counts, for example, here are lower for white than black, in fact, it's likely much higher because the unmarked terms refer to, most often refer to white people. So that's something very important thing to keep in mind. So this is why, for example, we didn't directly compare these two categories. But what we're doing is we are comparing these categories. We are comparing the proportion of Black terms in each book, rather like across books, rather than comparing within the same book the proportion of or directly comparing these two numbers, if that makes any sense. You will see it later, but there are some tricks that you can do, but it's very important to know these facts about your data. And know the biases it could contain. And there could also be, other tricks that, let's say, would allow us to get the better estimate of these counts. Here we are mainly trying to illustrate the sort of high-level natural language processing approaches, but there's really the ceiling is like infinity. So you could do a lot more and a lot more precise analysis. But yeah, I'm excited to show you what's coming, the results, because they're so very interesting. So basically, what we are now doing is correlating the counts or proportion or percentage of occurrence of a particular demographic with the political leaning of people who purchase those books. So let's say we want to understand if there is a correlation between how Republican the reader base the reader base of that textbook is, and how much they represent African American. So that's one of our main research questions. So what we have here, as I remember, I showed you before, each book is associated with a particular political affiliation kind of label, which could also be obtained in a lot of different ways. And here we have some plotting functions. You can go through this, and here we generated our plot, which is basically it shows a correlation between for in the case of women, a quite significant correlation. In the case of Black people, close to significant correlation, but not quite, between political affiliation and the percentage of terms referring to Black people in those books. So it's very interesting. And one thing to note here is that each of the books that are marked by triangles, that's why we said the shapes manually. So each of the books marked by triangles indicate books that are state adopted. So that means that they're officially recommended or approved by the state. And they tend to be a lot more conservative. So they are generally here, for example, 2 state adopted books are like the lowest. Same thing here. It's 2 different books, but no, actually, this is the same book. This is different. This is different. It's very interesting. And one other interesting thing is that how different methods can give you slightly different results, but still lead to very similar conclusions. So in our paper, we actually found also that they used the same trend, but the correlation for Black people was much more significant. And interestingly, it seems like the parser that we used gave slightly different outcomes because, the parser and tagger are the ones that identify the nouns. And so it's interesting that, they lead to similar conclusions, but the numbers are not exactly the same. So that's also something to keep in mind, that when you're doing analyses, and especially if, let's say, these results are key to your findings, just experiment with a bunch of different, algorithms or techniques, so to see if, they tend to generally lead to the same conclusions or not. So in our case, they do, but it's interesting that it's not the same. So yeah. So now let me just quickly check the time. Okay, I'm basically a bit over time. So the second component of this research, question 1, was understanding how often name or who is mentioned as a named entity and how often. So named entity, famous people, I don't know, Martin Luther King is a named person. So what we already did, step 0, was we ran Spacey, which automatically ran the name entity recognition for us. So we don't need to do that again. We have that parse data. So now what we need to do is we need to standardize these names, because sometimes it might just be the last name. Sometimes it may be a slight variation of the same name, let's say Martin Luther King versus Martin Luther King Jr. And they map onto the same person, but no, actually not, because it could be Martin Luther King's father. But I guess in the context of the history textbooks, it's more likely that it's going to be Martin Luther King Jr. for both. So what we're doing here is that we're using Wikidata, which is this database that can allow you to get demographic information for people, but also it can allow you to map different aliases to a particular name. It sometimes can, it's not a 1-to-1 mapping, or it's not even many-to-1. It sometimes can be many-to-many. But this is what we're using to at least get some sort of standardization. So what we're doing here is we're going through again all of our parsed books, and then we are looking at, for each line, the entities that are detected in that line, and if that entity is a person, and then we get the full, basically get official name. This is the function. And then basically you don't need to understand every detail of this, but you should feel free to look at it more closely. And then we get the candidates. There could be, as I said, multiple possible mappings. So get the candidates for what the official name might be, and then increment the counter for that official name for that person. So here we've already counted the famous people who are the most common famous people, and we saved that to a list. We also saved the dictionary that maps the name to the standardized version of that name. So that this also takes time to run. So it took also about 15 minutes, I would say, to run this, so or even more. So that's why I'm not running it here. So in such cases, when it takes time to run things, it's generally good practice to, save the intermediate results, in this case, the dictionaries or the text files or whatever you want, so that you don't need to keep regenerating it every time you run the notebook. All right, so the next next step is step 3, is matching last names to full names. So, it's very tricky because sometimes it can be ambiguous, like Roosevelt could refer to Franklin Roosevelt, Theodore Roosevelt, Eleanor Roosevelt, a lot of different people. So what we're doing here is really just, if there is a last name, we look at what was the most recent mention of that last name with the first name included, and then we map the two. So let's say if there's an occurrence of Roosevelt and there was a Theodore Roosevelt in the same sentence or paragraph, then we map it together. So so here we go through each text and do this. So let's see, like here we say, we replace Franklin Roosevelt with Franklin Delano Roosevelt. So it's not only last names, but it's also if we have a more standardized version of the same name. So you can check what exactly we're doing. And yes, so here, one another thing we care about is what are the demographic properties of each name. So like, let's say gender is an important thing. Unfortunately, besides gender, I don't know if age is very reliable, but besides gender, there isn't like race and ethnicity, for example, is not as accurate because for white people it's often not listed. So as I mentioned before, we had to do that, label that manually. But here I will show you how the analysis can be automatically run for gender. So for each of the books, we go through the named entities, and if its demographic attributes haven't been retrieved yet, then we retrieve it. Here the names are being printed out, and then we add it to a dictionary. So Wikidata dict will have a bunch of things, including an ID, and then a different, let me see, it will have different properties. So it will have the race and ethnicity and the gender. So we have over 1,000 name entities total, and we had 0 entities with multiple Wikidata entries. And then we put this dictionary into a data frame. So here, as you see, we have a particular entity, like a standardized name, then an ID in Wikidata. You see that none for a lot of the white politicians, there is none for their race and ethnicity. And then gender is pretty much present for everyone. And then there's occupation also, which I forgot to mention. And then there's a count. So there's also this person, for example, has only occurred 5 times in all books altogether. So I mean, I forgot to mention, but we only consider names that occur at least 5 times in at least one of the books. Okay, so we take the top 50 just because, that's what we reported in our paper. I'm curious what the demographic distribution of that is. And what we find is that there are only 2 women in the top 50 most frequently mentioned named individuals, which is very crazy. So in our paper, as I mentioned, we used a different parser, and we got that there was just 1 woman. Here we used the Stacy, and we got 2 women, which is also interesting that, the results are quite similar. 1 versus 2 doesn't, still very majority male, but interesting. So for example, can you guess who those 2 women are? So now you see 1. Eleanor Roosevelt is one of the women, and she was the one that we also found in our paper with using the parser we use that I'm referring to is a little bit more fancy parser. It's more accurate. It's one of the it was the state of the art at the time that when we used it. Space is a little bit lower quality, but as I mentioned, it's much easier to use it. So at least at the time you were, preparing this tutorial or like this toolkit, Spacey was a lot easier to use. So that's why we use this. But and I would say you can totally go ahead with Spacey. But if you're ever concerned about the results, you should definitely try comparing it to others. Especially if you're working not with non-English data, then you probably want to really check the accuracies. So here's the other woman, Jane Addams. So yeah, very interesting. They're both, yeah, interestingly, so here I can report, as I mentioned, the race and ethnicity distributions. I can tell you there are not very many. In our paper, we only found 4 out of the 50, which included Barack Obama, Martin Luther King, which I can see here, Frederick Douglass. So I can actually do this analysis right now, just like looking at what's oh, there's just 2. So as I said, this might need to be checked manually because there might be false negatives, but just Martin Luther King Jr. and Frederick Douglass, which is very unfortunate. Yeah, and and yeah, it just really highlights that the amount of space reserved to named individual, the amount of space occupied by named individuals is reserved to white male politicians with very few exceptions. So now I'm going back to the second. So these are just a couple of other results that we did with the counting people, like comparing it to student demographics. And one interesting, very striking finding is that Latinx people in these books are very, very much disproportionately underrepresented compared to the Texas student demographic. And as I mentioned, white people are mentioned even more often than this textbook shows, because their ethnicity is often unmarked. But I'm gonna just go to immediately the next. Oh, and also there's a gender discrepancy, even though student demographics are not roughly equal, men are disproportionately mentioned more often than women. And we do not expect to see a representation that is directly proportional to student demographics, but the distinction we find provides some empirical evidence for future research on how and why curriculum might shape students. So now I'm going to go to the next research question, which is, how are different groups and individuals described? And one, for example, a previous work showed that women occurred with less agentive and more passive words than men in Afghan history textbooks. We also, previous work has also shown that women are mentioned more in the context of the household and domestic spheres than men. And we really want to understand this. We see if we can understand and do such analysis automatically. So this plot, which we'll generate very soon, shows you like words that are more similar or occur with, to women. This top half of this plot shows words like that, and then words that are more similar or closer to men are in the bottom half. So I'll discuss how we obtain this, and I hope this will be interesting to you. So let me just again check my time. Okay, I don't have a lot of time. I have 7 minutes. So we use word embeddings, which are basically learned from word co-occurrence patterns in large corpora, and they're a standard way of representing word meaning in natural language processing. We learned embeddings for unigrams and bigrams in textbooks. So this unigrams and bigrams are basically single words or two words, and using the so-called word-to-back method. And in order to measure a similarity between 2 terms, we use cosine similarity. And here, so what I would highly recommend that you check out this awesome tutorial that describes word-to-back. And with the intuition behind it, basically the high-level intuition is that that, the word's meaning is defined by the company it keeps. So what context it occurs in. For example, river and lake would occur in similar contexts, hence their meaning is similar. And that's sort of the idea. And that describes how you can, how specifically word2vec, like how word2vec learns from these co-occurrence patterns and creates these low dimensional, you can set the dimension, low dimensional, like in this case, we use 300, but you can use 50, 100, whatever, depending on how precise you want them to be and memory and everything. You can learn these vectors and then do a bunch of cool arithmetic on them. Like you can compare, as I mentioned, you can, maybe this tutorial will not show that, but what we will show is that you can compare the similarity of words. You can also add words together. So, for example, women, so like man to king is the same as woman to queen. And you can do these algebraic, you can get queen from just simply adding the vector, there's a difference between king and man to the woman vector, and then you get the queen vector. So it's a very, very powerful method in natural language processing. So what we're doing here is we selected the set of man-related terms and women-related terms, and then we select a set of terms that are associated with homework and achievement. In the paper, we use a few more. Here in the tutorial, I'm just showing you a few, and then analyze basically how similar are they. So what, as I mentioned, I would recommend reading this tutorial. So right now, the state of the art is like a little bit more fancy than word2vec, but understanding how word2vec works is a very helpful step. Like basically, a lot of methods are very similar to, or even the state of the art, realizing similar iterations as this more simpler word2vec approach. And I would highly recommend reading this, because even if you're not that interested in natural language processing, it's a very cool idea. Okay, so what we're doing here is first creating a vocabulary. So basically you want to create a vocabulary that you can learn embeddings for. So the reason why we don't just learn vocabulary of single tokens, like single words, is because there might be terms that are two words and that defines their meaning. Like for example, I don't know, I can't think of something on the top of my head, but Oval Office means something different than office. And this is not the best example because there are cases of two tokens that really mean something very different from a single token. But there's just really let's say African American means something very different than if you just say American. Like unfortunately, they're used in different contexts. And so you want to understand, you want to get a vocabulary of frequently occurring, not just frequently occurring words, but not just words, but frequently occurring two terms. And we want to ignore stop words in between, like let's say Queen of Jordan would be sort of ignored, and then Queen of Jordan would be a diagram. So that's one example. So let me just show you how the vocab looks. So the vocab has, Christopher Columbus would be a two token, like Western Hemisphere. Again, I'm checking times. Okay, I only have 1 minute left. So just sort of quickly going through this. I think the key takeaway is this is a very simple model to run. It's just more the intuition behind it that you will want to understand. So it literally takes one line to take the model. You train 300 dimensional vectors, and we are using the Jensen library, which is also you can look at the packages that are loaded up on top to read more about the Jensen library, but it's a very cool library for doing a bunch of different natural language processing stuff, including topic modeling, for example, which is also very useful. And then here you're learning words. So for example, here's a set of query terms that designate women, and we see that here are the closest terms to women in our textbook. So obviously the same terms as we use as input, but then there's also husband, names of one, husband, wife. So here we wife and mother, Abikali, under woman, housewife, domestic servant, kissing. So so it's mainly names and just kind of weird, not as relevant terms. Well, not very, not a very broad range of terms that are closest to men. So I can do the same thing for men. Just very, very quickly. Let's see, because I have a men. Oh, it's giving me an error. Oh. Okay, I'm not gonna go. Yeah, this is okay. I'll fix this later so it will be accurate in the tutorial, but I don't want to waste more time. So basically, once we learn those embeddings, you can we have these set of query terms for men and set of query terms for women, and then we had set the words representing each of these categories, like home, work, and achievement. Achievement is a word category that we chose based on its frequent association with men, especially in the context of U.S. history or history. So we create a data frame that's basically has a query term, and then its proximity to women terms and proximity to men terms, and then a p-value for association. So the p-values are obtained via just the different terms, like how each of the terms contributes to the similarity. So so this plot. Okay, this plot shows you that a lot of the words that are in the home or domestic sphere are basically all of them are closer to women than men. Interestingly, all of the words that are in the work sphere are also closer to women and men, and that's actually consistent with previous research that did an inspection of history textbooks and found that in recent U.S. history curricula, women are mentioned very often in the context of the workspace space. And then we find that a lot of the achievement-related words are either similarly close to women and men or closer to men, which is perhaps also not too surprising, but interesting. Yeah, so feel free to look at this. In our paper, we did more careful analysis with bootstrapping, where we trained vectors for several iterations to get even better, an estimate of significance. Here, I'm just training a single model, but everything is described in the GitHub, and yeah, I hope that that this was useful and not too dense. But if you do have any questions, please just let me know. And yeah, I look forward to your questions and feedback. And if you need any help using our toolkit, which let me actually just put up that slide with, because I had a bunch of other slides prepared that I didn't really have time to show, but here is our paper and also our toolkit. And thank you.